Hi students, here I want to discuss about the latimer diagrams. The latimer diagram is related to the redox reactions. So first of all, what is the latimer diagrams? So latimer diagram means it is the list of various oxidation states of the elements. This is here I wrote here. It is the list of various oxidation states of the elements in which the elements arranged from the left to right in the decreasing order of the oxidation state is known as the latimer diagrams. Okay, here I arranged the elements in the decreasing order of their oxidation state. You know that here in this case oxidation state plus 4, because iron X oxygen minus 2 into 4 is equal to minus 2. Okay, so iron oxidation states here minus 2, so X is equal to minus 2 here 4, yes, 4 into 2 8, so here minus 2 plus 8 is equal to, yes, here plus 6, sorry, here it is plus 6, here plus 3, here plus, there plus 2 and plus 0 here, plus 6, plus 3, plus 2, 0. Elements are arranged in the decreasing order of their oxidation state. This is known as a latimer diagram. So definitions of the latimer diagram is it is the list of, I write here definitions, it is the list of various elements in which the elements are arranged from left to right, in the decreasing order of their oxidation state. The elements are arranged in the decreasing order of the oxidation state. So now I want to here say actually Fe4 2 minus 2 changes to Fe3 plus. What is the standard reduction potential is required here? Standard reduction potential required here 2.20 volt. Fe3 plus to Fe2 plus 0.77 volt. So Fe2 plus to Fe is minus 0.467 volt. Okay, so first of all I can write the reactions. So whatever the electrode reaction, I want to write this one here. So half shell reaction, write it, half cell reactions. So half shell reaction, first Fe2 to Fe0. So Fe2 plus 2 electron, they form Fe. Okay, electrode standard reduction potentials here equal to minus 0.47 volt. Okay, minus 0.7 volt. Second one, Fe3 plus, here see this there, Fe3 plus to iron. So Fe3 plus 3 electron, they form Fe. E0 value minus 0.057 volt. Next, Fe3 to Fe2 plus. Fe3 to Fe2 plus means 1 electrons here. 1 electron, they form Fe2 plus. Whatever this E0 value, standard electrode potential is 0.057 77 volt. Next one, this reaction Fe4 2 minus changes to Fe3 plus. So electrode reaction, FeO4 2 minus plus you have to balance the equation here. 3 electron plus 4 H2O. They forms, they studied this one first year itself, or I can write here 8H plus 8H plus gives Fe3 plus 4H2O balance equation 4H2O because oxygen 4H8 4H2O. Okay, so E naught value here 2.20 volt. Okay, so this is the half shell reaction for this equations. Now here question is, for the competitive exams they can ask this like questions. For example, I take an example for this one, an example for the reactions. The examples, this here questions. First Fe3 same, Fe3 plus 2 Fe2 plus Fe2 plus changes to Fe iron. They given here 0.77 watt. This one minus 0.44 watt. They ask find out the Fe3 to Fe, how much, what this value. Now this is actually, but remember actually these are the which types of reactions? Reduction reactions. These are the reduction reactions. The reduction reaction, if you add this sum, this reduction reaction not get the answer, final answer for this one. Suppose this is the oxidation reaction and this is the reduction reaction, then we get this answer here. E shell can be calculated, formula we know that. E shell is equal to oxidation potentials plus reduction potentials. Then we get E shells. But here the given reduction reaction, two reduction reaction, the sum of the two reduction reaction not give the final answer. So in such cases, you go for the thermodynamics concept. The thermodynamics, according to thermodynamics concept, how to find out the delta G? So here, I want to first find out the delta G naught or delta G1. Delta G1 is equal to minus N into F into E. We know this one. So this is for this equation here. For first equation, this is for this equation I taken as a delta G1. This is for the delta G1. This is for this reaction taken as a delta G2. Now sum of these two, delta G1 plus delta G2 gives a delta G. It is a conversion of a Fe3 to Fe. So totally you have to find out delta G3 or delta G. Delta G is equal to delta G1 plus delta G2, sum of these two. But delta G1 for Fe3 to Fe2 plus, delta G2 Fe2 to Fe. But delta G is for Fe3 to Fe. Okay. So here I write this is for Fe3 plus changes to Fe. Delta G1 for Fe3 plus changes to Fe2 plus. Delta G for Fe2 plus changes to Fe. Okay, Fe. So if you add these two sum, add this delta G1 plus delta G, you get a delta G. That's the final one. This is actually that's the delta G means Fe3 plus to Fe. So how to find out here? First of all, delta G1 find out. So delta G1 is equal to minus NF into E. So delta G1, minus N, number of electron transfer. What is number of electron transfer here? 1. Next, F is a constant. What is the E value? They given 0.77 into F. So answer is minus 0.77 F. This is the delta G1. What is the delta G2? Delta G2 is equal to same minus N into F into E. So what is number of electron transfer? Fe2 to Fe. Number of electron transfer is 2. So minus 2 E minus 0.44 into E. Sorry, F as it is, write it. The answer is minus 0.88 F. This is delta G2. Next, sum of this one. Here, sum of these two, delta G is equal to delta G1 plus delta G2. Delta G1, we know what's delta G1 value, minus 0.77 F plus this value minus 0.88 F. So delta G, what is the delta G? Once it changes from the Fe3 to this one, means minus N into F into E. So minus 3, number of electron transfer here 3. F, you have to find out, E value find out into F is equal to, we can add these two, we get to minus, if we add these two, final answer, we know that 8, here we add these two, 0.77, 0.88, 14, 15, here 15, 16, 1. So around answer minus 1.65. 1.65 is the answer here. So sorry, here one changes is there. Here actually minus here plus. So that's why here one changes plus. This one actually plus, not minus. Then you have to subtract it, not subtract 0.88, here 0.77, so 1, so 0. Here plus 0.11, symbol 0.011 F. So F gets cancelled here. So E is equal to 0.11 divided by 3, but symbol is minus. So final answer is around minus 0.037, approximately 337, get it here. Okay, so this is the answer, final answer. So this is actually, so what is electron volt is required, or volt is required conversion for this reactions. Fe3 to FeO is minus 0.037 volt is required for the conversion of a Fe3 to Fe. So these types of problems are totally important for the, especially for the G exams. This is from the latimer diagram. So totally here latimer diagram is a list of large number of elements arranged from the left to right in the decreasing order of their standard decreasing order of the oxidation state is called a latimer diagrams. Here, based on the latimer diagram, one problems. So use the following latimer diagram to predict. This is a given latimer diagram. We predict the number of Mn manganese species which is undergoes disproportionation. You know what is a disproportionation? So it is undergo both oxidation and reduction. Such types of reaction is called a disproportionation reactions or disproportion reaction. So the question is, number of manganese species which undergoes disproportionation reaction would undergo disproportion reaction. How many manganese species undergoes disproportion reaction? So how to find out here? So there are one concept you remember. First of all, to solve these problems, suppose we know that in generally E shell of the reaction is calculated by the E shell of the electro or galvanic shells. So galvanic shell means it includes the oxidations and reductions. So E shell of the galvanic shell is calculated by the formula the electrode potentials of the oxidation reduction potential, electrode potential plus reduction electrode potentials using this data. Electrode potentials, oxidation reduction electrode potential and oxidation electrode potential. We can find out E shells of the reactions. Okay. Suppose generally one example is given. The species A changes to A plus electrons. Now B gain one electron, they form say B minus. This is oxidation reaction, this is reduction reaction. Here suppose you just assume that some value is given for this. So this is suppose here 1.1 volt. This is a 0. This value is a 0.5. So whatever the net reaction, we just add these two, cancelled. We get the A. Okay. Here actually B plus, they form A plus B minus. So what is the E shells of this reaction? E shell is equal, just add here 1.6. This is electrode potentials. Okay. Suppose one point, remember, two oxidation reaction or two reduction reactions given. In such a case, we cannot find the E shells directly. Then you go for the thermodynamics concept. So here totally, what is the questions here? Number of manganese species which undergoes disproportion, means both oxidation and reduction reaction. So a first species, what's the given first one? MnO4 minus changes to MnO4 minus, means here +7 to +6. This is under which types of reactions? Reduction reactions. Means here +7 changes to +6. Oxidation state goes on, decreases. Okay. If oxidation state increases, they undergo oxidation reaction. Oxidation state decreases means reduction, but it not undergoes oxidation reaction because only one side, this side, but this side is not there. Correct. But you go for the second reaction, the second species, this is species, but this is undergo both types of reaction, oxidation as well as reductions. See, if you go for the forward direction, it is the oxidation state changes to +6 to +4. Here +6 to +7. Here oxidation status increases. Oxidation reaction. Here oxidation status decreases, reduction reactions. It will be changes, reduction, both oxidation and reduction. But my question, whether they undergo disproportion reactions or not. But before this one more concept. We know that any thermodynamics reactions, any redox reaction is feasible. Okay, E shell reaction is feasible only delta G is equal to negative and E shell becomes positive. Then only reaction gets feasible, otherwise reaction not feasible. This is a condition according to thermodynamics. The redox reaction is feasible only when delta G is negative, the E shell becomes positive. So if it is E shell is positive, no doubt this species undergo both redox and oxidation. That species, now that manganese species considered as a disproportion reaction or undergo disproportion. So now I can write equation separately, oxidation reduction and reduction reaction. So here MnO4 2 minus changes to MnO2 plus MnO4 minus. There are two types of reactions are possible. Here oxidation state is a +7. Here Mn2 +4. Here +6. Here +7 to +6 reduction. +7. MnO4 2 minus. So here +6. Here actually +7. So here plus 6 to plus 7, oxidation state increases, oxidation, this is undergo reductions. Okay. Now we find out the E shells. So E shell is the combinations of the oxidation and reduction reaction, combination of these two reactions. So here they given minus 2.26, okay, minus 2.26, sorry, here not a minus, plus actually this one, it is not a minus. So here minus, what is given, 2.26 watt. Now so this is which plus 6 to plus 4 forward direction, this is the backward direction. So that's why this is taken as a negative symbol. So minus 0.56 negative symbol, because this is a backward direction, this is a forward direction. So answer is must be the positive, not negative. So if we subtract 2.26, 0.56, here 12, here 7, here 1 point something, get it, but symbol, here symbol is important. E shell value is a positive, therefore this reaction is, this species undergoes both oxidation and reduction reactions. I go for the next case, MnO2, because both reactions are possible. So MnO2 changes to Mn3 plus reductions and changes to MnO4 2 minus oxidation. Both reactions are possible. So E shell is important for us. So E shell is equal to oxidation plus reductions. So here this value is 0.95, reverse minus 0.26. Total value is no doubt it's a negative. E shell is negative, redox reaction not visible. Therefore this species not undergoes disproportionate reactions. I go for the next one, Mn3 plus. Mn3 plus changes to Mn2 plus MnO2 here. So both types of reactions are there here plus 4. So E shell is equal to Mn2 plus. So what is this value? 1.51 minus 0.95, it is a positive, therefore this species Mn3 plus, it is undergoes both disproportions reactions. Now I go for the Mn2 plus. Mn2 plus changes to Mn, oxidation state changes 0, here Mn3 plus, so E shell is equal to, so you can add here minus 1.18, next here minus 1.51, no doubt it is always negative, so this is not undergoes disproportionate reaction. Even Mn also not, because only one types of reaction, two types of reaction not included here. This is no doubt here this not undergoes, it is also not undergo disproportionate reaction. So these two species, what are the species undergo disproportionate reaction here? MnO4 2 minus and Mn3 plus undergoes here number of manganese, totally answer is 2. Two species undergoes disproportions reactions. In the same problems, I give one more questions from the above problems. Use this latimer diagrams to predict the E0 value for the conversions of the MnO2 to Mn2 plus. Okay, this is also important question for the competitive exam, especially for the GE exams. So you find out the E0 value for the conversion of MnO2 to Mn2 plus. So I already discussed same types of one problems. So I repeated here same types of problem. In this case, this concept is based on the thermodynamics, because conversion of MnO2 to Mn2 plus, it is only one types of reaction, oxidation state goes on decreases. Okay, only one type, reduction reaction, not it involve the oxidation reactions. Therefore you go for the thermodynamics concept, means delta G naught value find out. So here you have to take a 2 delta G. So in this case, this is for the delta G1, this is for the delta G2, here Mn, here delta G2. Sum of this, conversion of this from here to, here 2 here taken as a delta G3, delta G. This is taken as a standard. So here I write, first of all I write separate equations, delta G1 for delta G2. So delta G1 MnO2 to Mn3 plus, so plus 4 oxidation states here plus 3, so 1 electron you can add it here, equation gets balanced. So E shell, it's a given 0.95 volt. Next one, Mn3 plus changes to Mn2 plus, E is equal to 1.51 volt, but here also we can add 1 electrons. Okay, add the 1 electron should be added here. Next, if we add the electron, these two equations you can add it. So Mn3 plus gets cancelled. So we get MnO2 plus 2 electron. They converted into Mn2 plus is correct, because here oxidation state is a plus 4, here plus 2, equation gets balanced. Then if E, here E is equal to how much you want to find out here. Okay, so this is based on the thermodynamics concept. So this is for the delta G1, it's taken as for the delta G1, this is for the delta G2, so this is for a delta G. So delta G is equal to sum of these two. So therefore I can write here delta G is equal to delta G1 plus delta G2. So delta G1, this is for the delta G1. So delta G1 value, you know that, minus N into F into E, plus this is also same, minus N F into E. So this is for the first one, this is for the second reaction. So here first cases, so N number of electron transfer here 1, no doubt, minus 1. So E, first I take this one 0.95 into F, E value, write it here. So second case, minus, so number of electron transfer here also 1. So E value is a given, so E value is 1.51 into F, correct. Then we can add these two. So here minus 0.95 F minus 0, here actually 1.51 F. So 0.95 here 1.51. So 6 so 9 14 1 to 2.46 minus 2.46 F. Okay, this next you have to simplify this one. So here, but what is delta G? Delta G is equal to conversions of this one, okay, plus 4 to plus 2. So same formula, minus N F into E. So minus, what is number of electron transfer here? 2 F into E is equal to minus 2.46 F. So F cancelled. So then we get E is equal to minus 2.46 divided by 2. Okay, so final answer 1 because minus 1.23 is the final answer. So this is the electropotentials required to conversions of a MnO2 to Mn2 plus is 1.23. These types of problems are important for the competitive exam. Thank you.